All right, so let's set a scene. You've got this high-end digital video source, maybe a media server, maybe a computer.
Right.
And you need that signal on a screen. But the problem is the screen isn't right there. It's, say, 300 feet away.
Yeah, and that's a total nightmare for standard video cables. I mean, you can't just run a 300-foot DVI cable. The signal just dies.
You get digital snow or, nothing at all.
Exactly.
So to fix that, for a deep dive today, we're looking at the NTI ST-C6DVI-IR-300 DVI Extender.
A very technical name.
It's a mouthful, yeah. But what it does is promise to bridge that 300-foot gap using just a standard Ethernet cable.
Yeah.
CAT5, 6, or 7.
Well, and that's the key. It's leveraging the infrastructure that, is probably already in your building's walls. This is all about efficiency.
So you're not pulling some thick, expensive DVI cable through the walls?
No, you're using a cheap, durable network cable to do the heavy lifting.
No, I was kind of expecting a simple little dongle, but looking at the source material, this is actually 2 separate, pretty rugged steel boxes.
It has to be. You need active electronics at both ends to push that kind of bandwidth. So you have a local unit at the source and then a remote unit at the display.
And the Ethernet cable just connects them.
It's the bridge.
Okay, so reading through the specs, something jumped out at me that, honestly, it solves a huge headache I've dealt with before. The whole system only needs one power supply.
Oh, that's a massive win. A huge operational benefit.
Right.
Because usually you'd need a power brick at your source and then another one plugged in behind the TV, which could be a real pain.
But this uses power over cable, so you plug the 10-watt supply into the local unit.
And it sends power down the line to the remote unit.
Which means you don't have to call an electrician to install a new outlet behind the monitor just for your adapter.
It saves time, money, and a lot of ladder climbing.
Okay, but there's another logistical problem. Your source is a football field away from the screen. How do I say pause the video? I can't walk 300 feet back to my desk.
They thought of that. They absolutely did. The extender has an IR loop, infrared. So you can plug an IR receiver into the unit by the TV. You point your regular remote at it, and the device just shoots that command all the way back down the Ethernet cable.
Against the flow of the video signal.
Yep. It's a two-way street. Video goes one way, your remote control commands go the other. It keeps the user experience feeling, seamless.
You don't feel the distance, but we have to talk about the physics. We're shoving a really complex video signal down a wire that was designed for, spreadsheets.
There's always a trade-off. There has to be.
So what's the penalty?
It's all about resistance and distance. The manual actually has this very specific chart. And if you're using a good SAPD6 solid cable at, say, 50 feet, you get a perfect signal, full 1080p at 60 hertz.
But I'm guessing that chart takes a nosedive.
It really does. It drops off hard. By the time you push it to the maximum 300 feet, you're limited to 480p resolution.
Wow. And to put that in perspective for everyone, 480p is basically old school DVD quality, if you put that on a big 4K screen.
It's going to look like a blurry, blocky mess.
Yeah.
Signal attenuation is the enemy. That's why the manual is so incredibly specific about the type of Ethernet cable.
It says you have to use solid core cable, not stranded. I've got tons of Ethernet cables and never once checked for that. What's the difference?
Well, most of the patch cables you buy are stranded. They're flexible because they have lots of tiny little wires twisted together inside.
Okay.
That's fine for connecting your laptop to the wall, but it has higher electrical resistance. Solid core is just one thicker piece of copper. It's stiffer, sure, but it's a much better conductor. For 300 feet, you need that solid path or the picture just falls apart.
Speaking of the picture, let's look at the timing specs. Jitter is listed at 1.2 nanoseconds, and latency is 40 nanoseconds. Why include numbers that are so incredibly small?
Because it's about stability. Think of jitter as a stutter. If the timing is off, even by a tiny amount, the screen can flicker or tear. A jitter of 1.2 nanoseconds is, well, it's basically non-existent. It means even if the resolution drops at a distance, the signal itself is rock solid.
So it's built for precision environments where you just can't have the screen going black.
Exactly. And at $420, it's priced like professional gear.
So to sum it up, it's a solution that uses cheap wire to solve an expensive problem, but you have to respect the laws of physics.
That's a very fair way to put it.
All right, before we wrap up, what's the one thing from this deep dive that's still sticking with you?
It's that distinction between solid and stranded wire. Just has these huge implications for buildings that are already built. We all assume, oh, this place is wired for Ethernet, we're good to go.
Right.
But if the contractor used stranded cable in the walls because it was easier to pull, this device just won't work at its full potential. It makes you think, doesn't it?
Hmm.
The invisible copper geometry inside your walls literally dictates whether you can have HD video or not.
A great reminder to check the fine print on the wire before you start drilling holes. Thanks for listening to this deep dive.